Space is filled with strange worlds, planets where it rains metal, worlds with oceans of lava. But one discovery stunned astronomers for a different reason. Through powerful telescopes, NASA and international researchers found a giant exoplanet so incredibly hot that it appears to glow like a piece of burning glass fresh from a furnace. It isn't on fire, it isn't a star, yet it shines with its own eerie orange light across the darkness of space. How can a planet glow bright enough to be detected from hundreds of light years away? The answer reveals one of the most extreme environments ever discovered. The planet is known as WASP-76b, located roughly 640 light years from Earth in the constellation Pisces. It belongs to a class of worlds called ultra-hot Jupiters, gas giants that orbit astonishingly close to their stars. Unlike Jupiter, which takes nearly 12 years to orbit the Sun, WASP-76b completes an entire orbit in less than 2 Earth days. That means one side of the planet is constantly blasted by intense stellar radiation. Temperatures on its dayside reach nearly 2,400 degrees Celsius, hot enough to melt iron and many types of rock. At those temperatures, the atmosphere doesn't just become hot, it becomes incandescent. Instead of merely reflecting starlight like Earth or Jupiter, the planet itself radiates visible light because it is glowing from extreme heat, much like molten glass inside a glassblower's furnace. Scientists call this thermal emission. For the first time, astronomers weren't simply seeing sunlight bouncing off a distant planet. They were directly detecting the planet's own glowing heat. That changed everything. Observations from NASA's Transiting Exoplanet Survey satellite, TESS, and other powerful observatories allowed researchers to measure tiny changes in brightness as the planet orbited its star. When the glowing planet disappeared behind its star, the total light reaching Earth dropped ever so slightly. Those tiny drops revealed something extraordinary. The planet itself was producing measurable, visible light, not because it was burning, but because it was unimaginably hot. Imagine standing near molten glass in a factory. Even without flames, the glass glows bright orange. Now imagine an entire planet behaving the same way. But heat wasn't the only surprise. Because WASP-76b orbits its star so closely, gravity has locked one side permanently toward the star, just like the moon always shows one face to Earth. This is called tidal locking. One hemisphere experiences eternal daylight. The opposite side never sees sunrise. The temperature difference between these two worlds on the same planet is staggering. Powerful winds, estimated to reach several kilometers per second, race around the planet, attempting to carry heat from the blazing dayside to the cooler nightside. These may be among the fastest planetary winds ever inferred. Then came one of the discovery's most astonishing findings. Using high-resolution spectroscopy, astronomers detected evidence of iron vapor in the planet's atmosphere. On the scorching dayside, iron doesn't remain solid, it evaporates into gas. As those powerful winds carry the vapor toward the cooler nightside, temperatures fall enough for the iron to condense, not into water droplets, into molten iron. This remarkable process led scientists to describe the possibility of iron rain falling through the atmosphere on the nightside. It's unlike anything seen anywhere in our solar system, yet it follows the same laws of physics that shape weather on Earth. Clouds form, temperatures change, materials condense. Only here, the rain isn't water, it's metal. And that raises an even bigger question. If planets this extreme truly exist, how many even stranger worlds are still waiting to be discovered?
The discovery of glowing heat and possible iron rain made WASP-76b one of the most fascinating planets ever studied. But astronomers were still missing something important. What exactly gives this world its strange appearance? To answer that question, scientists looked deeper into the planet's atmosphere. Instead of finding a calm blanket of gas like Jupiter's, they discovered an atmosphere constantly changing under impossible conditions. Molecules that are stable on Earth simply cannot survive here. Many are torn apart by intense ultraviolet radiation from the nearby star before they can reform again. This creates an atmosphere in a constant state of chemical chaos. Every orbit provides another opportunity for telescopes to analyze tiny fingerprints of light passing through the planet's atmosphere. By splitting that light into a spectrum, researchers can identify individual elements and molecules with astonishing precision. This technique, called transmission spectroscopy, has become one of astronomy's most powerful tools. Without ever visiting these distant worlds, scientists can estimate their temperatures, atmospheric composition, wind patterns, and even cloud properties. In many ways, they are reading the chemistry of a planet hundreds of light years away, using nothing more than its light. Then another mystery emerged. Computer models suggest that the intense heat may create clouds unlike anything found in Earth's skies. Instead of water vapor, these clouds could contain vaporized rock and minerals that later condense into tiny particles. Imagine a sky filled not with soft white clouds, but with microscopic grains of minerals drifting through a glowing atmosphere. Combined with the planet's own thermal glow, this could produce an eerie, glass-like appearance. One reason descriptions such as glowing like burning glass resonate so strongly, even though the planet itself is a gas giant rather than a solid glass world. Every new observation reminds scientists that nature often creates environments more extraordinary than science fiction. The study of planets like WASP-76b is about far more than discovering bizarre weather. Each extreme world helps researchers understand how planets form, evolve, and survive under conditions completely unlike those in our own solar system. Some gas giants migrate inward after formation. Others may have formed close to their stars from the beginning. By comparing dozens of ultra-hot Jupiters, astronomers are beginning to uncover the hidden history of planetary systems throughout our galaxy. These discoveries also prepare scientists for the future. Powerful observatories, including the James Webb Space Telescope, are providing far more detailed measurements of exoplanet atmospheres than ever before. They are detecting molecules, measuring temperatures with greater accuracy, and revealing atmospheric dynamics that were impossible to observe just a decade ago. Every improvement in telescope technology opens another window into worlds once thought forever beyond our reach. Perhaps the most remarkable lesson isn't that a planet can glow, it's that the universe continues to surprise us. Only a few decades ago, scientists didn't even know whether planets around other sun-like stars existed. Today, more than 5,000 confirmed exoplanets have been discovered, and every year that number grows. Some resemble Earth, some orbit dead stars, some race around their suns in only a few hours, and some glow with the intense heat of a cosmic furnace, their atmospheres shaped by temperatures capable of vaporizing metal. WASP-76b reminds us that our solar system is only one small chapter in a much larger story. Somewhere in the darkness, countless other worlds are waiting to challenge everything we think we know about planets and perhaps even about life itself. The universe is not running out of mysteries. We're only beginning to find them.